Hey guys, I bet you're really excited to be watching this video right now. Okay, we are looking at polynomial inequalities, okay? So a lot of times when we're solving things with variables, we have an equal sign, right? We're looking for what x or what our variable equals. But here we have an inequality, so we are looking for a range of numbers that x can be, right? Okay, so my first thing I'm gonna do is I wanna get everything on one side. So I have all my numbers and variables on one side and 0 on the other side, okay? So to do that, I'm just going to add 8 to both sides, okay? So when I do that, I end up with x cubed minus 2x squared minus 4x plus 8 is greater than what's left over here is 0. Sweet, this is what we wanted, okay? All right. Next thing I'm going to do is probably your favorite thing, factor, okay? I was kidding. It might not be your favorite thing, but if it is, that's cool. So I'm going to factor this pretty quickly. If you need a review on factoring, I'll link a video. But I'm going to pull out an x squared from those first two numbers. So I end up with x minus 2. And I'm going to pull out a negative 4 from those guys. And I end up with x minus 2. So now I can pull out that x minus 2, right? And I end up with x squared minus 4 times x minus 2. Okay, and then I notice that's a difference of 2 squares. So it factors to x plus 2 times x minus 2 times x minus 2. Or I could have written that as x minus 2 squared, either way. Okay, so now we're going to write it over here again. If I were to multiply these all out, I'd get this, right? Okay, next thing I'm going to do, okay, is I know this isn't an equal sign, but knowing where these equal 0 is very helpful. And if you're kind of like, why, I'll show you at the end why this is very helpful, okay? So I'm going to set each of these equal to 0, okay? So I'm going to have x plus 2 equals 0 and x minus 2 equals 0. And I have 2 of those, right, which would just give me both the same answer, so I don't necessarily have to write them twice. If you were graphing it, we would want to take note of that, but for now, it doesn't really matter. So we're going to subtract 2 from both sides, so I'd end up with x equals negative 2, and add 2 to both sides, so I get x equals 2, okay? Now I'm going to draw a number line. Yes, we love number lines. They're our favorite thing ever. Okay, and I am going to put these 2 points on my graph, okay? So I'm going to have negative 2 and 2. This is just kind of a rough sketch. It doesn't have to be perfectly to scale or anything. It's just to help me get a good idea of what's going on with this polynomial, okay? So if I were to plug in negative 2 for x, I would get 0 is greater than 0, which isn't true, right? But it is helpful to know where it equals 0 because it's kind of like a boundary, okay? So I'm going to put an open circle at negative 2, which tells me that's where it equals 0. But since for this inequality, it can't actually be 0, I use that open circle, okay? If it were greater than or equal to, if it had the line under, I would do a closed circle, okay? I'm also going to put a circle at 2, okay? All right. Now, I want to know what range of numbers will make it so that this, when I plug in a number for x, will be greater than 0, okay? So is it the numbers less than 2? Is it the numbers between negative 2 and 2? Or is it the numbers greater than 2? That's what we're going to find out, okay? So what I'm going to do is we're going to test some points and do what we call sign analysis, okay? So first, I'm going to pick a number that is less than negative 2. Let's just go ahead and pick negative 3, okay? So if I plug in negative 3 to this, I'm not too worried right now about what the actual number answer would be. I just want to know if it's going to be positive or negative, okay? So if I plug in negative 3, I would get negative 3 plus 2, which would give me a negative, right? If I do negative 3 minus 2, that would give me another negative. And if I do negative 3 minus 2, that would give me another negative, okay? Negative times a negative gives me a positive. Positive times a negative gives me a negative, okay? Whew. So I know the numbers less than 2 are going to give me a negative answer or less than 0 answer. Okay. Now, if you're like, that sign thing was weird, I'd rather just figure out what the numbers are and multiply them, you go ahead and do that. Okay. All right. Next, I need to plug in a number between -2 and 2. So let's go ahead and plug in 0. Okay. So when I plug in 0, 0 plus 2 would give me a positive number. 0 minus 2 would give me a negative number. 0 minus 2 would give me a negative number. Okay. Positive times a negative would give me a negative. Negative times negative would give me a positive. So this range is going to be positive. Okay. Again, if you're like, why does this work? I'll show you at the end. Okay. All right. Now we need a number bigger than 2. You could pick like 1,000 if you wanted to, but I'm just going to pick 3. So let's plug in 3. 3 plus 2 would give me a positive. 3 minus 2 would give me a positive. And 3 minus 2 would give me another positive. Okay, 3 positives multiplied together would give me a positive. Okay, so this range is positive. Okay, this is when I go back to my polynomial and it is asking when this polynomial is greater than 0. So greater than 0 would be when it's positive, right? So this range of numbers between -2 and 2, if I were to plug in any number between there, I would get a number greater than 0. Also, from 2 up, if I were to plug in a number bigger than 2 for x, I would also get a number greater than 0. Okay, so this is my answer, but your teacher probably doesn't want your answer as a number line, even though I think it's beautiful. Okay, but your teacher probably wants the answer either written as an inequality or in interval notation. Okay, so let's go ahead and write it as an inequality first. Now, I wish I could just write x can be anything greater than -2, right? But that's not quite true because it can't be 2. Because if I plug in 2, I get 0 is greater than 0, which isn't true, right? So basically, x can be anything bigger than 2. Sorry, anything bigger than -2, just not 2. So how do we write that in inequality form? So we say -2 is less than x is less than 2, right? Doesn't that represent this section, right? Because I could plug in 0 there. 0 is bigger than -2 and less than 2, right? Or x can also be greater than 2. That represents this section, right? Okay, so there it is in inequality form, right? So if I were to pick a number that fits either of those categories and plug it in, I'll get an answer greater than 0. Okay, all right, for interval notation, we're going to say that x can be anything between -2 and 2. And I use parentheses because that shows it can't actually be -2 and 2. Those are just like my boundaries, okay? And then it can also be any number from 2, or bigger than 2, to infinity, okay? Infinity always gets a parenthesis. 2 gets a parenthesis because it can't actually be 2. If it could be like -2, you use a bracket, okay? And then we do a U in the middle to show that these guys are united. They're together. Okay. All right. So that shows me what I can plug in for x to make this statement true. Okay. All right. Next, I promised that I would tell you why this works. Okay. First of all, I want you to think if we were graphing this polynomial. Okay. If you need a review on how to graph polynomials, guess what? I'll link a video for you. Okay. If we were graphing that using like end behavior, multiplicities, this may sound familiar, my graph would cross or touch the x-axis at -2 and 2, right? Remember when we set them equal to 0? So if I were graphing this polynomial, I know my graph would touch or cross the x-axis at -2 and 2. And again, using what I know about end behavior and such, I know it would look something like that. Okay, that is what this graph would look like. You can go ahead and even plug it into a graphing calculator and make sure. But where is my graph greater than 0? Well, look, guys, it's greater than 0, right, above the x-axis between -2 and 2. And since it's not equal to, we don't count the 2, right? And then from 2 to infinity, right? That's where it's greater than 0. So that's why this sign analysis thing worked, okay? Isn't that cool? I think it's so cool. But I also make math videos in my spare time. So, okay, I hope this made sense. And if you need some more examples, I'll link a playlist. Thanks.